Welcome to the next video in the Oregon FFA Forestry Career Development Event Series. In this video, we'll wrap up the process of timber cruising by calculating timber volumes. Once we have our measurements, how do we determine how much wood is actually in a tree? How do we measure that volume, and what do we do with it? We'll walk through the final steps of the timber cruising process, taking our earlier diameter and height measurements, figuring out how much of the tree is actually usable, and turning that into an accurate estimate of the product from the land.
I'm Jerry Risk. I'm a forester with Roseburg Forest Products. So when we're talking about cruising in the industry, there's really two main types of cruises. There's an inventory cruise where you're going out and you're gathering that data for what's out on the landscape as the trees are growing. The other one would be a merch timber cruise or a merchantable timber cruise, where we're going out to a timber sale that we may be interested in purchasing, and we're cruising it with a lot of the same methods, but we're also looking at quality of the wood, and we're really trying to gather not only how much volume is on the landscape, but also the quality of the wood that's out there in the landscape. So when we're doing an inventory cruise on our timberlands, we're measuring tree heights and diameters along with some other data, and all of that data is then plugged into our growth models that are showing us how many board feet is currently in that stand down to a 6-inch diameter top, because that's what our mills are set up to take. And over time, we start getting a growth model or a growth curve, and we can see how fast that stand is growing, and then it starts to slow down. When that growth curve, we start looking at that, we start looking for a percentage value called NPV, and once it hits a certain percentage, that's basically saying that the tree is still growing. The tree is going to grow in perpetuity forever, but at that point, it's slowed down enough that it makes sense to come in, harvest that, and replace it with a new tree that's going to be growing at a faster rate, putting on more volume, and being the next generation of timber.
As we get ready to calculate the volume of a stand of timber, the first thing to remember is that our height measurements, taken with the laser or clinometer, go to the very top of the tree. But the entire tree isn't usable. The uppermost part doesn't have a thick enough stem to produce lumber. For this CDE, we'll calculate volume to an 8-inch top. Different companies may use other standards, like a 6-inch or even a 4-inch top, but for us, it's 8 inches. So how do we know where the tree reaches 8 inches? Instead of just estimating, we'll use a simple rule of thumb to figure it out. Here's the rule. To find the merchantable height, the usable length of the log, start with the total tree height. If the diameter at breast height, the DBH, is less than 20 inches, we're going to subtract 15 feet from the top. If the diameter breast height is 20 inches or more, subtract 20 feet. That gives you the merchantable height, the part of the tree that's actually usable. Next, we'll divide the merchantable height by 16 feet to determine the number of logs. In our case, one log equals 16 feet. Different companies or organizations may use other lengths, but we'll stick with 16 feet. Finally, round down the result to the nearest half log. Let's see that in action and do an example. In example 1, the tree has a diameter at breast height of 22 inches and a total height of 104 feet, again measured with our clinometer or laser. Since the DBH is 20 or greater, we subtract 20 feet from 104, giving us a merchantable height of 84 feet. Now, divide 84 by 16, and we get 5.25 logs, which we record as 5 logs, rounding down to the nearest half log. 5 logs is our answer. Here's another example. This tree has a DBH of 19 inches and a total height of 78 feet. Since the DBH is under 20, we subtract 15 feet, giving us a merchantable height of 63 feet. Divide 63 by 16 to get the 3.93 logs, which we always round down, in this case makes 3.5 logs. Now that we know the number of logs in this tree and we have the original diameter, we can figure out its volume. Let's see what this actually looks like. For tree number 3 on this page, we have a DBH of 24 inches and a total height of 104 feet. Since the DBH is over 20, we subtract 20 feet, giving us a merchantable height of 84 feet. Next, divide that 84 by 16 to get 5 logs. Now that we know the tree has 5 logs and a 24-inch diameter, we can use a volume table to determine the actual board feet in the tree. What we're looking at here is called a Scribner decimal C volume table. It works by combining the diameter breast height, the DBH, which is listed on the left, with the number of logs going across the top, which we determined earlier by defining the merchantable height and dividing by 16. For the tree we just calculated, with a DBH of 24 and 5 logs, the table shows a board foot volume of 770 board feet. The Scribner table has been around since the 1840s and was one of the first ways to calculate board feet from a round log. According to OSU Extension and the United States Forest Service, it is still one of the most common ways the board foot is calculated in the Pacific Northwest. The decimal C version rounds values to the nearest 10 to simplify the math, which is why every number on the table in front of us ends in 0. Older versions of the table often left off the 0 entirely, so instead of seeing 770, you'd see 77 and need to multiply by 10 yourself. Fortunately, this table shows the full numbers, so our final answer for this tree is 770 board feet. Here's one more example of how to use the table for a certain scenario. Earlier, we calculated a tree with 3.5 logs, but the table only shows whole numbers, 3 logs and 4 logs. That's simple to handle. Since the actual DBH was 19, but the table is in the nearest even inch, we round down to that nearest even inch, 18. Then, for the 3.5 logs, we average the values for 3 logs and 4 logs at 18 inches. In this case, at 18 inches and 3.5 logs, we would average 280 board feet and 330 board feet by adding them together and then dividing by 2 for a final answer of 305 board feet. One important note, sometimes defects in the bole of the tree can affect the number of usable logs. Examples include a fork, a broken top that regrew sideways before growing up again, or a large sweep in the butt log. If such a defect occurs within the merchantable height, meaning more than 15 or 20 feet from the top, we account for it by subtracting half a log from the total before calculating volume. This adjustment reflects the lumber we'll lose due to the defect. However, if the defect is within the top 15 or 20 feet, where the top would be less than 8-inch diameter, depending on the DBH, it's outside the merchantable height and doesn't affect our calculation. Now that we've calculated the volumes of the trees in our plot, typically 5 trees for the CDE, we can determine the plot volume and then the board feet per acre in the stand. A forester doesn't measure every tree on an acre when they cruise. Instead, they take a sample and extrapolate. Start by adding the 5 individual tree volumes listed on the right-hand side of our table to get the plot volume. Once we have this total, we can then calculate the per acre volume. On here, it says our plot is 1/10 of an acre in size. So if that 1/10 of an acre contains 2,590 board feet in our plot, we must just simply multiply that number by 10 to find the full acre contains 25,900 board feet. If we'd been told our plot was 1/5 of an acre, we would have multiplied it by 5. That's how you find the plot volume and then the per acre volume. Calculating timber volumes is the final step in the timber cruising practicum of the Forestry Career Development event. This is real-world application of math skills. After measuring tree diameters and heights, determining merchantable height, and calculating the volume of each of the 5 trees, participants add those volumes to get the plot volume, then extrapolate to find the per acre volume. Participants are scored on their accuracy in measuring diameter, calculating the number of logs, and estimating the tree's volume. Partial points are awarded for answers that are within a certain percentage of the correct answer. Other videos in this series will cover additional practicums in the Forestry Career Development event, including compass and pacing, map reading, and timber stand improvement.